Hello, this is section 5.3, inequalities in one triangle. Actually, this is a pretty easy section. It's got three theorems, but there's one that's kind of tricky, and it's more tricky for just keeping track of things. And we'll look through it some in the video, but we'll spend a lot more time on it in class. So, um, we're still working with proving theorems about triangles, not standard. But looking at the then, we found relationships between angle measures in a triangle. Now we're going to talk about inequalities with measures of angles and then inequalities between angles and sides of a triangle. So first, definition of inequality. An inequality is any real number, a and b, and we'll say a is bigger than b if and only if there's a positive number c that you would add to b to make b and a equal, the sides equal. So for instance, here we go. I know 5 is bigger than 2 or 3 because in order for it's 5 is bigger than 2 and 5 is bigger than 3 because I have to add 3 to 2 to make 5 and I have to have 2 to 3 to make 5. So it's bigger than either of those. So hopefully that makes sense. If not, I'll show up in a second here how we're going to use this. Other properties, comparison. We can say that a is less than b, a is equal to b, or a is greater than b. There's no other thing that can happen between two numbers. Transitive property of inequality is kind of weird. We don't use it very often, but if a is less than b and b is less than c, we would know that a has to be less than c. Or conversely, if a is greater than b and b is bigger than c, we know a is bigger than c. Addition property, if a is greater than b, you can add the same number to both sides. It still says a is greater than b. If a is less than b, you can add the same number to both sides and a will still be less than b. Same thing with subtraction. Subtract the same thing and stays true. Subtract the same thing and stays true. So here is the first question I got for you. It's a theorem question. All right, now, the question was about the exterior angle theorem. And what the exterior angle theorem said in section 4.2, I think is what it was, the two remote interior angles, A and B, to the exterior angle, which is angle 1, those two guys add up to be angle 1. Okay. Now, here's the important part of this. Since A plus B equals measure of angle 1, I could say measure of angle 1 equals measure of angle A plus measure of angle B. I can't write for some reason all of a sudden. And by the definition of inequality, since it takes A and B together and they're positive, and that's the key because you can't have a negative angle yet, but you'll learn how to do that in algebra 2, but not in geometry. Since those are both positive, if angle 1 is A plus B, that means that angle 1 is greater than angle A, and measure of angle 1 is greater than measure of angle B, by using the definition of inequality, basically. Since these two guys have to make angle 1, hey, one has to be bigger than A and one has to be bigger than B. So that's our first theorem for today. Theorem 5.8, the exterior angle inequality. If you've got the measure of an exterior angle of a triangle, sorry, let's start from the beginning here. The measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. And again, it should make sense. If A plus B equals 1, one's got to be bigger than A, one's got to be bigger than B. Okay, so here's our first problem looking at this. So we want to use the exterior angle inequality theorem to list all angles whose measures are less than 4. What this question is really asking us to do is to sort out, for angle 4, what are all of its remote interior angles? Because if it's a remote interior angle, then 4 is bigger than it. Okay, now, there are a few triangles in this drawing, but here's angle 4. Angle 4 is the exterior angle. So here's its first triangle. Right there, that it's an exterior angle for. Now, obviously 4 looks bigger than 3, but to be honest, we really can't make that claim because the drawing could be doing something weird like this. Oh, that had to be something even weirder, wouldn't it? Here we go. Like this, where here's angle 4 and here's angle 3. We just know that they make a linear pair together. So it's kind of annoying because you should say your eyes say, no, 4 is bigger than 3. But I can't make that claim because all I can say is that 4 and 3 add to 180. However, angle 2 and angle 5 are a couple of its remote interior angles, so I know that angle 2 and angle 5 have measures less than angle 4. Plus, there is another triangle in here. This guy here, that angle 4 is an exterior angle 4. So if 4 is bigger than, or if 4 is the exterior angle, it has to be bigger than 7 and 8 and 2 together. Well, 8 and 2, I already know it's bigger than 2. 8 and 2 together means it has to be bigger than 8 as well. So there we go. 2, 5, 7, and 8. So that's really what, there's a lot of stuff going on in this drawing, and I know we're going to struggle with it, and we'll talk about it in class. But this problem here, the key is 4 is the exterior angle, 2 and 5 and 8 and 7, well 7 specifically, but 2, 5, and 7 specifically, but 8 is part of the remote interior angles, so I know it has to be bigger than those. Again, I know 4 looks obtuse and 6 looks acute, so does 3, but I could draw them so that they're not, and I can't make that claim then. So it's the key is, what are the remote interiors? Okay, so the other two theorems I think are quite a bit easier to sort out, to be honest. They're almost common sense theorems once you realize what's happening. So, angle side relationships. Okay, if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. Okay, it seems weird and strange until you look at the drawing here. We are saying, first we know that xy, which is 9, is bigger than yz, which is 7. So what that's saying is, okay, since that's opposite the bigger side, that's the bigger angle. And then this is just the converse of this, basically. If one angle of a triangle has a greater measure than another one, then the side opposite the greater angle is longer than the side opposite the lesser angle. Again, it's a complicated way of saying, oh look, angle J's got a bigger angle. Its opposite side, LK, is bigger than angle K, which side's JL. Now, the easiest way to think about this, even though this isn't the true way to think of it, because we're going to have something called the Hinch theorem, is if you think about a triangle, let's take an equilateral triangle for a moment. We know all the sides are congruent. We know that all the angles are 60 degrees. Okay. So all the angles are congruent, all the sides are congruent. That's from last chapter. If I just do this, if I just say, look, I'm going to keep this side the same length and keep this side the same length. What will happen is when I open that up a little bit, that makes this angle even bigger. And what happens is these two sides stayed the same length, but this side here had to spread out and become more open. So now once the angle's gotten bigger than 60, this side's got even longer itself. And it works the other way around. You know, and again, if you just think about it, like let me draw an obtuse triangle. Well, in an obtuse triangle, this is the biggest angle, that's the biggest side. In fact, in a right triangle, the biggest angle is a 90-degree angle, the biggest side is the hypotenuse. So, like I said, it's kind of a common sense theorem. Hopefully it makes perfect sense. And of course, if it doesn't, come in, we'll go through it and talk through it together. So in this problem here, they're asking us to list the angles in order from smallest to largest. Okay, well, what's got the largest opposite side, or smallest opposite side? That's 11.1, so angle C. And then which side is the second biggest side? BC, well, that's angle A. And then what's got the biggest side, or the one that's left over? Angle opposite side B, so angle B. Okay. So smallest side, smallest angle, medium side, medium angle, biggest side, biggest angle. All right, same thing here. List the sides of triangle ABC in order from shortest to longest. Okay. Well, the shortest side has to have the smallest opposite angle. Smallest angle is B, so opposite side of that is AC. The middle one has to have the middle angle. Well, 55 degrees is the middle angle, so the one opposite that is AB. Not ABG, AB. And then the angle at the biggest opposite, the side with the biggest opposite angle is angle A. It's got 80 degrees, so its side is BC. Okay, so if you got any questions, please come in. Like I said, that first one's a weird theorem, and we're going to spend most of our time in class talking about it. But if anything else pops up, those other two that, again, like I said, are kind of common sense. If they're not, come in. We'll sort it out together in the morning. Thanks.